we have the chain rule. This is a function that's a function of another function. So you have multiple functions nested inside of each other. So there's a process that you follow to take the derivative of something like that. We have something called the product rule. Product rule is how you take a derivative of two things you multiply together. And then the quotient rule, two things that you divide. Is there is there actually a real need for having a product rule and a quotient rule? There isn't. Any quotient you can write as a product. How many of you like the quotient rule? Probably don't like any of the rules, but the quotient rule really sucks. It's confusing. So I'll show you how to write that as a product rule so we can get some answers to these. So I'm going to go through these rules for derivatives, and I'm going to show you and walk through how to do these examples. Okay? And then you've got a nice long sheet of 20 derivatives to take. Okay? In addition to that, on Canvas, there are additional practice problems for you to do. Practice problems related to vectors and dot products and scalar products. So you're going to do those as well, and those you're going to turn in as assignments for this week. I pushed the due date back for those to be due, I think, what day did I make them due? Wednesday, I think, but they're not due today. Tomorrow? They're due tomorrow at 11:59. Okay, so I'm giving you a little bit of extra time beyond class time. Okay, so the power rule. How do we do the power rule? That is a big, chunky marker. So the power rule. The general form of it is f of x equals a times x to the n power. So a is just a number, x is your variable, and n is the power that you're raising it to. To take the derivative of this, your number that's out front, so we'll call this f prime of x. Are we all familiar with the prime notation for a derivative? So when you put a prime next to something, that means you're taking the derivative. Keep the constant. Take the exponent, bring it out front. Take your variable stays, and take your exponent and raise it to the n minus 1th power. That is the general formula. And you can use that formula for anything raised to a power. So if I have the function f of x equals 5 times x to the 4th, let's follow this really, really general classification scheme. First, I write down a. In this problem, 5x to the 4th, what is a? 5. So I take 5. Then I take the exponent and I bring it down. N. What's n in this problem? 4. Then I take my x and I write down my x. I raise it to the n minus 1 power. What's n minus 1 in this one? 3. So if I write this out, f prime of x equals 5 times 4 is 20, x to the 3rd. Let's do another one. So I have f of x equals 5t cubed minus 3t squared plus 8t to the 5t minus 3 over 8q r, no, qp. We'll do qp. You see your faces. If future YouTube people watching this, you should see their faces. They look terrified. What's the derivative of this with respect to x? You got a minute to work on it? Caduce has an answer? Caduce is living in a dream world. He thinks this is 0. Got to make it really easy.
It is.
It is?
The variable of the function is x, and you've defined the function in terms of t.
Yeah. The only variable here is x. So if I'm taking a derivative with respect to the variable, if there's no x's in your equation, those are all just constants. As far as this derivative is concerned, t is a constant. T is a number. Q is a number. P is a number. Anything I write that doesn't have an x is just a number. So what's the derivative of 5t cubed with respect to x? 0, because there's no x's in it. Derivative of 3t squared with respect to x is just 0. I could make this derivative a lot harder. I could say take the derivative of this with respect to t. Then this would be a pain in the butt, right?
And you lost.
It wouldn't be too bad. Well, we won't bother with that. Just want to point out, you're always taking derivatives with respect to a specific variable. And in this class, your variable is only going to be one direction. You're not going to have to take multi-directional derivatives. They're not that much harder, but we won't make you do it. Okay, so you always make sure that you're looking at your variable. Any questions on the power rule? Nope. Okay, we got the chain rule next. I always hated the chain rule because they write it so obscurely. It looks really funky. So I've got a function of x, f of x, and this is f. And then we have another function, g of x, that's inside of that f of x function. And then they write this general formula, f prime of x equals, oh gosh, what is it? F prime of g of x that's g of x. And then I have to look this up. G prime of x. Okay. That's the general formula. Is that helpful? Anybody find that helpful?
Without context.
I think the power rule one is kind of helpful. I can see how that one works. I don't see how the hell that thing works. Makes no sense to me. So let's do an actual example. So if I have function f of x, and this is where I really think of the chain rule and using it. 5 times cosine of kx plus 5t. So I could think of this as having two different functions. My f function and my g function. So my g function is whatever inside of everything else. So I have an f function, f of x, is 5 times the cosine, and g of x is what's inside of that cosine. So my g of x function is kx plus 5t. What's the inside? Function inside of another function. Now to take this derivative, I need to take the derivative of f of x. So what's the derivative of 5 cosine g of x? What's the derivative of cosine? Negative sign. So I have the constant stays with me, 5 times negative sine, kx plus 5t. And then the biggest mistake people make when doing derivatives of trigonometric functions like this is they forget the chain rule. The chain rule, you have to take the derivative of whatever inside of the sine function. You have to take the derivative of the function inside of the other function. So I have to take the derivative of kx plus 5t. I lost a 5. Okay, so what's the derivative of kx plus 5t? Okay. Is it plus k plus 5? Why not k plus 5? I see a 5t. It's not x. Only a function of x. X's are the only ones that matter. So there's my derivative using the chain rule. Don't forget to take the derivative of whatever on the inside of your nested function. Okay, chain rule. Any questions on the chain rule? Nope. Okay. We're all very tired today. I think it's a Monday. Anybody do anything fun this weekend? What did we do? What fun things did we do this weekend? Work. Fun thing.
The beach.
You went to the beach? What beach?
Virginia Beach.
Virginia Beach. It's a long drive. Anybody else? Can anybody beat Virginia Beach?
I tried an Indian restaurant.
Tried an Indian restaurant. Okay. They're having fun up here. What are we having fun in the back? Huh? Your cousin's wedding? Where was that? New York? New York City? No? What part of New York? Lake George. Okay. Are you over 21? Okay, then the wedding was fun. That's a good guy. Anybody else? You went to Houston?
Yeah.
That's a long trip.
It is.
For how long?
It was only from like Friday to.
What'd you do? Anything fun?
Yeah, I went out and stuff.
And you're over 21?
Yeah.
Okay, so that would be fun too.
It was very
Chess
fun.
piece. Chess piece.
Anybody else?
Yeah.
Yeah? You went to a concert last night? What concert did you go to? Lil Nas X. I went to a concert too. Can you guess what concert I went to?
There's a statue there.
I didn't go to Lil Nas.
What else you run?
I went to Elton John concert. That seems on brand. 70-year-old man, 75 years old. Went to the concert at 8 o'clock. I figured we'd be out by 9. He was going till 11. Pretty good for an old man. Yeah. Playing 8 till 11. Been moving, conscious, impressed. Okay, product rule. How do we do the product rule? Product rule is when you have two things that you're multiplying together. F of x equals, let's say, a function a of x times b of x. F prime of x, the derivative of the product, is the first function times the derivative of the second, plus the second function times the derivative of the first. So it's not bad, it's just you got to keep track of stuff. So if I have a function f of x, let's say it's 3x times 5x squared plus 1. In this little setup using my general formula, what is my function a of x? 3x? What's my function b of x? 5x squared plus 1. Okay, so I need to take my derivative, f prime of x. Bless you, whoever sneezed. Okay, so I need to take a of x and write a of x down. What's a of x? 3x times b prime of x. I need to take the derivative of b of x. What's the derivative of 5x squared plus 1? 10x. I bring the 2 down. 2 times 5 is 10. X to the 2 minus 1 is 10x. So this is 3x times 10x. What about the plus 1? What's the derivative of 1? Respect to x is 0 because it's just a constant. So that's first times the derivative of the second. Now I need to add the second. What's the second function? I have a of x times b prime of x plus b of x times a prime of x. What's b of x? 5x squared plus 1 times the derivative of a of x. 3. First times derivative of the second plus the second times derivative of the first. That's the product rule. Yay. Okay, quotient rule. Quotient rule sucks. I hate the quotient rule. Quotient rule killed my mother. Quotient rule is awful. F of x equals, let's say it's a of x over b of x. Then f prime of x, oh my goodness. B of x times derivative of a of x minus a of x b prime of x all over b of x squared. Holy shit. Who wants to do that? That's horrible. Horrible. Okay, let's look at a function, f of x equals a sine kx divided by 4x cubed. Who Who wants to know the trick to never have to use the quotient rule? Who wants to see the algebra? Let's do that algebra. Yay! 2 people raised their hands, YouTube. This is exciting. F of x. I'm telling you, the 3 guys in India that watch my videos are really going to enjoy this. A times sine of kx. And then anything that's in the derivative, if I raise it to the -1 power, I can bring it up top. So if I write it like this, times 4x cubed to the -1, and I've done it. I've rewritten this as a product now. Yes? You need to make sure that the 4 is to the -1 as well. So you do 1/4 x to the. So I can work with it from here. So as we were saying, you need to simplify this kind of. So a times sine of kx. Let's get that variable, get that exponent brought in. 4 to the -1 is 1/4. So we'd have a 1/4 here. And then this would be x to the -3. You prefer the quotient rule? Somebody prefers the quotient rule. Hey, you could do that. You'll get the exact same answer. Okay, so I can do, let's keep writing this out, f of x. 1/4 is just a constant, isn't it? So I'm going to multiply that with the a so that this is just a over 4. So all my constants are there now. Times sine of kx times x to the -3. And now I can do this with the product rule. F prime of x equals first a over 4 times sine of kx times the derivative of the second. What's the derivative of x to the -3?
-3x.
-3 times x to the -4. Okay. First times the derivative of the second plus the second variable, x to the -3, times the derivative of the fourth, which is going to be a to the 4, a over 4. What's the derivative of sine? It's just plain cosine of kx. And what do I have to remember to do because of the chain rule? Take the derivative of that inside, and that is k. There's my derivative.
Like, imagine, this one's easier because you took a polynomial function as a divider. Now, if you have, let's say, sine kx over ln x,
Now I have 2 people saying the quotient rule is better, YouTube. Tell them in the comments how wrong they are. And I'll come back.
You have to do the chain rule for the quotient.
Now, chain rule sucks. You'll never convince me otherwise. Okay, so you have practice problems for the derivatives. So work on these practice problems. You will never convince me the quotient rule is better. You're welcome.
I mean, it was in his personality terms. Yes, he was a positive. One of the things a positive.
And then work on those vector problems as well. You will not get fully worked solutions for any of the vector problems. You have answers to work towards, but no full nicely, you don't need a calculator for any of these. Yes, ma'am.
If I was to break this down into a derivative, I know we do close and we do these functions. Because this is an entire derivative. What would this be as a derivative?
Derivative of a sine kx. Same as the way we did the chain rule up here.
this would be the outer term and this would be the inner. Okay.
So take the derivative of the enemy a cosine kx, and then derivative of the inside part.
Things just
Yeah. Practice those.
I will.
I've been doing the product rule and quotient rule for 24 years. Product rule.
So this using the product.
Huh?
So this using the product.